All right, so 2-6 talks about rational functions and most specifically asymptotes. When you graph rational functions, which are functions that look like a fraction, so it's something divided by something, and here you've got some real examples of what they might look like. There may or may not be a variable in the denominator, most likely there is. But if you try to graph those on your calculator, depending upon your calculator, most of them aren't going to show the asymptotes. And the asymptotes represent places that your graph cannot cross, values that it's not possible for your graph to have based upon the variables in the denominator and the numerator. Okay, so this is what all of this is about down here. You're going to have to find the following 6 items on each and every graph. So number 1, your domain. So as you're looking at a function that is a fraction, how is the domain restricted? What can there not be on a fraction? The denominator cannot be 0. So do I care about the numerator with the domain? No. If there is a variable in your denominator, you're going to set that denominator equal to 0, right? So that's how you're going to find out what your domain is. So you might want to put that kind of in parentheses. Set denominator, whoops, that should be an n, equal to, or not equal to 0, I guess, technically. And then that's going to tell you, so look at the one up here. What can x not be up here? Negative 3. So, well, just on this one here. So negative 3, right? So that's not what your domain is, right? That means your domain cannot be negative 3. Anything but negative 3. How do you show that in interval notation? So your domain would equal negative infinity to what? To negative 3. And we put a parentheses, right? Because it cannot equal negative 3. And then a union, right? Negative 3 to positive infinity. So that's how that domain would look. And then this one is negative 3 and negative 1, right? So this one would look like this, but then this would go from negative 3 to negative 1 here. You'd have another union, and you'd have negative 1 to infinity, right? So this one would have 3 parts to its domain. You want me to show you that one too? Okay, so for this one, for this domain, so from here, if I've got negative 3 and negative 1, and they go in that order on the number line, I'm going to go from negative infinity to negative 3, union. Then I go from that negative 3 to negative 1. So anything in between negative 3 and negative 1, but not including those, union. Then negative 1 to positive infinity. Right? So that's what those domains would look like. And all I did was set them equal to 0. When we find the domain, we've also found, by the way, our vertical asymptotes. These two find the same thing. Or you find these two the same way. Doesn't this one say denominator can't be 0? And I'll show you what a vertical asymptote looks like in a minute. So when you find the domain, you find that vertical asymptote at the same time. Then we have to find our x and y intercepts. Remember, when we find our x and y intercepts, you are going to let y equal 0. And this one says, or your numerator equaling 0. I'll show you what that means in a minute. On the y-intercept, you're going to let x equal 0, and then you're going to solve for y. This one specifically, you are always going to plug 0 in for x and find y. Why is it that if I let y equal 0, so look at these, if this said f of x, isn't f of x the same as y? So if that were f of x and I let that be 0, is there any way that this function could be 0? What does the numerator have to be for a fraction to be 0? 0. Is there any way for that numerator to be 0? Okay, so for this particular one, there is no x-intercept. It will not cross the x-axis. What about this one? The only way for this fraction to turn out to be 0 is if the x plus 2 is 0. Agreed? It really doesn't matter what the denominator is. If I get the x plus 2 to be 0, what's 0 divided by anything? 0. So that's why this is saying let your numerator equal 0. So on this one, I would just set x plus 2 equal to 0. So what would x end up being? -2. So for this one, my y-intercept, my x-intercept would be -2. My y-intercept, you're going to plug in 0 to each of these x's. So what's 0 plus 2? 2. What's 0 plus 3? 3. 0 plus 1? 1. What's 3 times 1? 3. 2 over 3 is 2/3. So the y-intercept for this one would have been 2/3. And you'd have to plot it 0, 2/3. All right, then you have a horizontal asymptote, which remember horizontal asymptotes go that way. And there are some interesting ways to find the horizontal asymptote. This one is kind of a pain. There are 3 tests, well really one test you apply and 3 results. So here's your 3 results. Your numerator, the degree of your numerator is less than the degree of your denominator, something happens. Look at the degree of your numerator. If it's equal to the degree of your denominator, something happens. And the last one, if the degree of your numerator is greater than the degree of your denominator, something happens. So these are your 3 different situations. Situation A, situation B, and situation C. So let's look at each one of those first. How do you find the degree of a polynomial? It's really easy. How do you find the degree of a whole polynomial? The degree of the highest term in that polynomial, right? Well, you have to look at it in its non-factored form. What would the degree of this one have been if we multiplied it out? X squared, wouldn't it? And isn't the degree of this one what? What's the highest degree term? What's the degree of a constant? Nope, 0. Because the variable associated must be to the 0 power. The degrees always come from the variable string attached. And so this is the highest degree term, and doesn't it have an exponent of 1? So this has a degree of 1. If we multiply this out, it has a degree of 2. Does that fall into the situation where the numerator degree is less than the denominator degree? True or false? Yeah, because this is 1 versus 2. This is less than this. Because it's less than this, then here's your asymptote. And they also give an example here. See how this is squared? What's the degree of this one? Cubed. So this is less than this. And so we end up with y equals 0 as our asymptote. If the degree of the numerator is less than the degree of the denominator, you have y equals 0 as your asymptote. What is y equals 0? What line? Y equals a number goes through which axis? Yeah, it goes. So this is really the x-axis, isn't it? Y equals 0 is the x-axis. So what they're saying is the x-axis is going to be your horizontal asymptote. This graph will approach the x-axis but never ever cross it. Okay? All right, then if your numerator degree is exactly equal to your denominator degree. So here's an example. We have 2x squared over x squared plus 1. Then look what you're going to do. You're going to take your leading numerator coefficient and divide it by your leading denominator coefficient. So what's the leading numerator coefficient here? 2. So this is going to equal 2 over, what's the coefficient of the leading denominator term? 1. So we get 2 over 1, and so that equals 2. So then we end up with y equals 2. So if the numerator is exactly equal to the denominator, take those 2 coefficients of the highest degree terms, put one over the other, and reduce. And then y equals 2, isn't that horizontal? Goes to the y-axis at what point? 2. All right, then your last situation is here, where your numerator degree is now higher than your denominator degree. So here's an example where I have x cubed over x squared. Your results? No horizontal asymptote. So not everything has a horizontal asymptote. The only time you don't have 1 is if the numerator's degree is higher than the denominator. So this is the part you really have to pay attention to, is what do I have here? Then your slant asymptote, which is really lesson, I'm going to go ahead and lecture on it now, but this is really lesson 2-7, in case you're wondering in your book where it came from. The slant asymptote means that it's going to be at a diagonal. It won't be vertical, it won't be horizontal. And all you do is take your numerator and divide it by your denominator. That means that you're going to be using synthetic division. So use synthetic division. And also you might want to add this. Pardon? Oh, see? Look at there. But here's an important thing, that you don't always have a slant asymptote. The only time you have a slant asymptote is when the degree, let me move this up a smidge, when the degree of the numerator must be exactly 1 degree higher than the denominator. If not, no slant asymptote. Mike, we don't put our heads on our desks. So sit up, pay attention. So which one of these would have a slant asymptote? Which one of these is there? And so this only happens if your numerator is greater than your denominator degree, correct? Okay. So C is the only situation where you would also have a slant asymptote, so long as the difference between the highest degree in the numerator and the denominator were 1 apart. Would this have a slant asymptote?
Yes.
Yes. All right, this is one we probably wouldn't want to do synthetic division on. It'd be interesting, but easy. We'll talk about it. You won't probably get one like that. All right, so let's go ahead and do synthetic division here. Am I missing any terms? Nope. So I have 1, -1, and -2. There's my remainder, there's my shelf. What am I putting in the shelf? Set this equal to 0. What would the 0 be? 1. So then go ahead and do your work. So you're not necessarily going to get a 0 remainder. Most times you don't. So this means I have no constant, right? Doesn't this mean that that's an x? So what I have here is x minus, my remainder is 2 over x minus 1. This right here, this is your slant asymptote, not the remainder. So your slant asymptote in this case would just be y equals x. Your remainder, if you look at what your book says, this remainder approaches 0 as x approaches positive and negative infinity. In other words, the bigger that x gets, both positive or negative, the closer this number appears to be 0. So the point is, your remainder doesn't have a lot of effect on your asymptote. So look at the part that's not the remainder, and that's the equation y equals whatever you have here. So if I had had a 4 here, my asymptote would have been y equals x plus 4. It's going to be in the form of y equals mx plus b, right? Because you're graphing a line and it's a diagonal line. All right, so we're going to use all of this on the back. You ready? Yes.
How do you have to put the shelf again?
Because this is not given to you as a 0, you have to find what the 0 would be if that were a 0. And so set x minus 1 equals 0, you're essentially taking the opposite sign, right? All right, so flip it to the back. So we have to find all of those pieces. And then we're going to graph it down below here. So let's start with number 1. What's the first thing I have to find? Domain. So look at your domain. How is x restricted? Tell me what x can't be. 3. So how are you going to write that in interval notation? Negative infinity to 3, union 3 to positive infinity. Right? So that's number 1. Then number 2. What do we have to find for 2? X intercept. All right, so X intercept, what are we going to do? Okay, we want y to be 0. And remember, for the X intercept, if I want y to be 0, which is your f of x, is there any way for this to become 0? Remember, you set your numerator equal to 0? Can you set this equal to 0? No. So is there a x intercept? No. So you're going to put none. All right, then our third thing is what? Y-intercept. What do you have to do for that? You want to find f of 0, right? Because you're letting x be 0. And so I'm going to plug in 0 in here. 1 over, instead of x, I'm putting in a 0, minus 3. What do I get? Negative 1/3. So you have to write your y-intercept as an ordered pair. You just found y, right? Aren't we letting x be 0? So our answer for this is 0 for x, negative 1/3. You okay so far? Okay. What's our fourth thing? So our fourth thing, we're going to find a vertical asymptote. Vertical goes this way, right? What do you do? It's the same as what? It's the same as the domain. Once you find the domain, you found that vertical asymptote. So didn't we set the denominator equal to 0? And what do we get? So we're going to set x minus 3 equal to 0. And so our x, or our vertical asymptote, would be x is equal to positive 3. And then what is our fifth thing? Okay, so horizontal. What is the degree of the numerator? 0. What is the degree of the denominator? If you don't have any variables in the numerator, that's why it's 0. What's the degree of the denominator? 1. 0 is less than 1, isn't it? So according to what you have on this side, we have our numerator is less than our denominator. So what's your asymptote? Y equals 0. So put here for your notes, numerator is less than your denominator. Y equals 0 for your horizontal asymptote. Okay, what's left? Slant. Is there a slant asymptote for this one? The numerator degree has to be exactly 1 higher than the denominator, and we actually have the reverse, right? So aren't we going to put on here none? So none for the slant asymptote. So we're going to plot some. So the very first thing that I like to do is put in my vertical and horizontal asymptotes. So my vertical asymptote is x equals 3. So use your straight edge. And you absolutely positively must label these. If you don't label them, you will end up losing points. So this is x equals 3. And then my horizontal asymptote is y equals 0. Even though it's your x-axis, notice I'm making them dotted lines. Why? it doesn't actually, it's not actually part of the graph. So when your horizontal asymptote is the x-axis, you better still label it as y equals 0. And don't miss that. And then we had no x-intercept, and that makes sense because our x-axis is a horizontal asymptote, which means our graph shouldn't cross it. We have a y-intercept of what? 0, negative 1/3, right? So here's a point right there. I know it's crossing. Now you're going to get used to the fact that this graph looks like this. It's going to hug those asymptotes and go in those opposite directions, and it's going to hug and go through that y-intercept and come up to this asymptote here and hug that. Did I plot any other points? No. And then we're going to put that on our calculator. I'm going to show you how close we got. So go to y equals, and make sure that you put this as 1 divided by, in parentheses, the x minus 3. So it looks like that, right? Then when you graph it, some of your calculators might have the asymptote line in there. It just means that you possibly have a program that you wrote in there that does it. But my calculator will not show that. So, but it looks like there's a vertical line here. It's just part of it's missing, right? That should be at x equals 3, which it is. And then it looks like it's approaching and just touching the x-axis. It's really not touching the x-axis. So did we graph an accurate picture? Yep. Pretty good job. All right, so let's look at example 2. We're going to do exactly the same thing again. Start all over again. What's my domain? How do I find it? What can x not be? 1, right? So I'm going to go from negative infinity to 1, union 1 to positive infinity. Step 2, x-intercept. X-intercept, what do we let equal 0? Y. So if I let y equal 0, we only care about the numerator. So we're going to take 1 minus 3x and set it equal to 0. Solve for x. What does x equal? Positive 1/3, because these are both negative, right? Aren't they both negative? Okay. And so my x-intercept is negative 1/3 for my x value, 0 for my y value. So I would actually go right down here on the x-axis and plot that right now. Oh, sorry. Yeah, I said that, and then I went and put that in there. Sorry. Good thing you're awake. All right, so then I have a positive 1/3, 0. There's my x-intercept. No. If you get it labeled up here, I'm totally fine with that, so long as you've said x-intercept is. If it's labeled up here that way, you don't have to label it on the graph because it just gets all bunchy in there. All right, so then we need our y-intercept. What are you going to let equal 0? X. So we're going to do f of 0 equals, so 1 minus, and then 1 minus. So I'm going to let my x's be zeros. What do I end up with? What over what? 1 over 1, which is 1. So my y-intercept is x is 0, y is 1. So I'm going to plot that on my axes right there. Then we have to find our vertical asymptote. What do we do for a vertical asymptote? Yeah, we already found it with our domain, didn't we? We set 1 minus x equal to 0. And what do we end up with? Up here in our domain, what do we end up with? 1. Yeah, so our vertical asymptote is x equals 1. So we're going to go ahead and plot that in here right now as a dotted line. And label it. And then 5, our horizontal asymptote. What is the degree of my numerator? 1, because that's the highest degree term, right? What's the degree of my denominator? Also 1. What happens when the degree equals the numerator? Yeah, you take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. So what is the leading coefficient of the numerator? You might want to put in here, numerator equals denominator. So what's the leading coefficient of my numerator? -3. And my denominator? -1, which equals 3. So because it's horizontal, it goes to the y-axis, so it's y equals 3. So I figured out that my degree of my numerator was equal to my denominator, right? Okay, so you're okay with that. Then look at your leading coefficients, the ones that you used to figure that out with. That term and that term, right? Isn't the leading coefficient here -3? It doesn't matter that it doesn't come first. And then this one, wouldn't it be -1? So that's all I did. Put -3 over -1, numerator over denominator, got 3. Sometimes it's a fraction, it can be. And so then I'm going to plot that with a dotted line. Y equals 3. And then we have one last thing to do, right? Slant. Whoops. If my n was equal to my d, is there a slant asymptote? To have one, what does it have to have? 1 degree higher than the denominator, and so that doesn't happen here, so there is none for this one. And you actually have to write none, otherwise I don't know that you know it's none. So we have our two asymptotes. What do you think, where do you think my graph is going to be? It's going to look like this one. Where do you think this one's going to be? We have an x and a y-intercept, right? And if these are asymptotes, it means our graph hugs it. So we're going to go from here and hug this asymptote. And then we're going to go up to here and hug this asymptote. Same thing here, but we're just going to go like this. Done. Now we're going to put in our I almost said put it in our phone. I guess we're not really putting it in our phone. All right, so I got to use double parentheses. So parentheses, 1 minus 3x divided by 1 minus x in parentheses. Can you see the asymptotes that aren't actually there? Yep. So I have one going through here, right? One right there. And then I have one right here. Right? Anybody's calculator actually show the asymptotes in there? Amber, can I see yours? So this is what hers looks like. Now hers is showing the vertical, just not the horizontal. Right? Some of yours might actually do that. But you need to be well aware that it's not part of your graph. So it should be a dotted line. Your calculator doesn't make that distinction. Thank you. Yes. Can I do what? Plug it in again? So look at your y equals. Does yours look like mine?
Yeah.
Yes? Does your graph not look like mine?
No, it does. Is that all we do?
That's it. So you can check your graph, right? Because you want to check it. But did I need a calculator to graph it? No. I had enough information that I could graph it without. But you have to be aware of what the graphs look like, right? Sometimes they could be over here. How did I know that they weren't over here? And they'll always be diagonal to each other. How did I know that? Your x and y intercepts, right? That kind of told you where it was. All right, so then look at the bottom. We're going to look at transformations. So So we have the general form of 1 over x. So let's just walk our way through this. 1 over x, does it have a vertical asymptote? What can x not be? 0. So isn't the y-axis an asymptote? Y equals 0. Does it have a horizontal asymptote? What is the degree of the numerator? 0, right? If it's just a number, the degree is 0, if it's just a number. What's the degree of the denominator? 1. What is the horizontal asymptote when the numerator is less than the denominator? Look in the front. Y equals 0. So isn't the x-axis of y equals 0? Yeah, I wrote this one wrong. Oops. All right, so aren't the x and y-axis my asymptotes? Is there an x intercept? There's nothing in the numerator, right? Is there a y-intercept? If you let x equal 0, what's going to happen? You have 1 over 0? It's undefined, isn't it? So there's no x-intercept, there's no y-intercept. Is there a slant asymptote? No. All right, so shouldn't the graph look like this? And mind you, if you plugged in positive 1, so here's your, let's just plug in positive 1, 1. Wouldn't my point be right there for positive 1, 1? And I'm going to use this, whoops. I'm going to use this as a translation point for you. What if we plugged in negative 1? What if I plugged in negative 1 here for x? What would y be? Negative 1. So if we went to the left one and down 1, wouldn't that be a point on the graph? So wouldn't it be going through here? And so this is negative 1, negative 1. I want you to look at what happens to those points, because this is essentially the same graph, but we have a plus 3 in the denominator. Let's see what that does. What does it do to our vertical asymptote? What can x not be? How does this affect our vertical asymptote? All right, so let's write over here, just for chuckle's sake, vertical asymptote, VA, was x equals 0. Horizontal asymptote was y equals 0. Okay? Let's do the same thing over here. Vertical asymptote, set this equal to 0, what do you get? Negative 3. So x is equal to negative 3 is your vertical asymptote, right? So look at what happened. It moved our vertical asymptote. What's our horizontal asymptote? What's the degree of the numerator? 0. What's the degree of the denominator? 1. Is it the same as the horizontal asymptote before? Yeah. So what did the plus 3 do? Well, it moved it 3 to the left, didn't it? So you might want to put here, it is sliding. Well, let's say, yeah, we're going to say shift 3 to the left. Because it's happening to x, isn't it? So it's shifting our x 3 to the left. So here's our new asymptotes. Let's put them in blue. So x equals negative 3, and I still have to label y equals 0 here. Now, remember we went from the very middle here, we went 1 to the right and 1 up. So doesn't that mean that I move my x to the left 1, 2, 3? So if I chose an x of 1, I should now choose an x of 1, 2, 3. Isn't this negative 2? So what is negative 2 plus 3? 1. What's 1 over 1? 1. So we go 1, 2, up 1. So again, it didn't change the height of that point, but it just moved that point 3 places to the left, didn't it? So this is now -2, +1. So this point down here, I originally went to the left 1 and down 1, right? So if I chose -1 and I'm going to the left 3, what's 1, 2, 3 to the left of -1? What x is that? -4. So what's a -4 plus 3? -1. What's 1 over -1? -1. So we go 1, 2, 3, 4, but down 1. So this point is -4, -1. Again, the height of the point didn't change. It's still down 1. It just moved to the left 3. And so your graph still has the same shape, still hugging the x-axis, but this time it's hugging that vertical asymptote there. So it's just a shift left 3. Okay, now look at what happens when you add something outside. So remember how I talked about adding something inside the argument versus adding something outside the argument? Isn't this like adding inside the argument? Didn't we have an opposite sign change, a shift to the opposite sign, so to speak? What do you think is going to happen here? It's outside the argument, isn't it? It should go up 4. So it's no different than what we've learned in the past. So this is a shift up 4. And I'll prove to you that that's what happens. So, a vertical asymptote. What can x not be? 0. So x is equal to 0. So from the original one over here, has the vertical asymptote changed? No. What about the y asymptote? Or the y asymptote, the horizontal asymptote? What's the degree of the numerator?
0.
0. And the degree of the denominator is 1. So it still appears like you have this one here. It still thinks like it should be y equals 0, but the problem is this is not a full fraction. It's not a fraction over a fraction, right? So the fact that this is outside and you're not dealing with one whole fraction because it's a fraction plus a number, you can make it into one fraction if you want to, but this is going to end up shifting up 4. So instead of going through all that work, if I were you, I would just know it shifts up 4. And so that horizontal goes up to here. You know, you'll actually have plenty of time to pack up when I'm done with notes. So what's going to happen to this point that I had down here at 1, 1? It goes up 4, so won't it be at 1, 5? Over 1, up 5. So this should now be 1, 5. And this point that was at -1, -1, it's going to go up 4 as well. 1, 2, 3, 4. So that point is at -1, 3. So then your graph looks like this. And this one actually has a y intercept, right? Okay. All right, so that should finish out your notes. You only have 3 problems.